Hi cohort, one last video this week, a little bit about multiple regression, and it might help us understand a little bit better what went on Sunday and might help us get ready for what's probably coming up the next time we get together. A lot of questions I think people had based on last time's conversations was, when would we ever do this, or what's regression used for? And so what I thought I would do is try to do an example of how in my practice I might consider using multiple regression. And so hopefully that would make what we did on Sunday make a little more sense as well. Because I have a Mac, I'm not able to use SPSS. It just doesn't work really well. So what I'm going to do is I'm going to show you how I've been doing my homework on a different platform called StatCrunch. I just find it easier to use. And I'm going to demonstrate how I might use multiple regression in my practice. Okay, so the first thing I'd like to do is I'd like to load in some data. So let me show you some data that I made up. So I made up some data on test scores. Let's see if I can find it here. Multiple regression, example, voila. Okay. So I'm just putting my data into my program, and this program, StatCrunch, is just like SPSS. It does everything SPSS does. It's just slightly more user-friendly. Okay, so what I did is I made up some data, but I collect this data on my classes anyway, but I just have made up data on 8 students. One column is their test score. One column is how many minutes they spend on homework, because I use an online homework system that tracks how many minutes they spend on their homework. One column is their quiz scores for the unit, and one column is how many hours per week they work. So I might be curious, do any of these variables of how much time they spend on homework, how well they did on a unit quiz, and how many hours per week they're working, do any of those factors, or do all of those factors, contribute to what their test score came out to be? And if so, which factors contribute the most? Are any of them irrelevant? Are any of them more relevant than others? So that's what multiple regression can actually tell us. Multiple regression can tell us which of these factors, if any, and in what combinations, contribute or explain what the test score is going to come out to be. So what I'm going to do is I'm going to ask my computer to do a multiple regression. So I'm going to come here to regression, multiple, linear. So my y variable, my outcome variable, my dependent variable is going to be test scores. And I'm curious if test scores are related to homework, to quiz scores, and to work. In simple linear regression, what we were covering last weekend, you're only going to have one variable. For example, is our test scores related to homework, or are test scores related to quizzes? In that case, you're running simple linear regression. When you say, hey, there's many factors that might influence a test score, and you're going to look at all those factors at the same time, that's called multiple regression. Okay, so let's take a look. Now, my program's kind of cooler than SPSS. It can do this little extra thing that I'll show you, but because I think it'll help you understand a little bit about why we do multiple regression. Okay. And so here are the tables, the output. And this is very, very similar to what SPSS puts out. So if I look at the 3 tables in Sheldon's handout, the first table, which is the summary, let's see where that would be in my program. My program gives a summary at the end. But remember we talked about in the last video the R-squared value? Can you see down here the R-squared value? 0.95. That means that there is a tremendously strong correlation between the 3 variables that I've put in and test scores. These 3 variables are very highly correlated with how students did on the test. So again, this is what we would see on the top of an SPSS output, the summary, and what we look at right here is R-squared. When we see 95%, we're going, wow, that is an incredibly strong correlation. Okay, the middle chart in SPSS, the one that has the ANOVA, in my, well, here it is. I guess mine is just upside down from SPSS. So right here, this is what is my ANOVA table, analysis of variance table. What do you look for in that table? Simply test statistic, p-value. See my p-value right here? 0.0006. It's tiny. It's close to 0. A p-value close to 0 means you reject your null hypothesis. In this case, we reject that there's no relationship. Thus, we conclude there is a relationship. So our p-value here tells us, yes, there is a relationship between test scores and all the variables we have in the table. This one right here is the third table in Sheldon's handout. It's the parameter estimates. So here we have the intercepts, the quiz score, and the work. Okay, and it gives you a p-value for each one. Since these p-values are all very small, what it tells us is that quiz scores and hours working are very strongly related to test score. What I had guessed my program to do was something up here that I don't think SPS does by itself, but you might probably are able to set it to do it as well. We might be curious which ones were the most powerful predictors, and the reason my program only gave me quiz and work here instead of quiz, work, and homework is because the number one predictor, the best relationship, see how 92% our R-squared value, this is the highest one, that ranked number one, were quizzes, quiz scores, and number of hours worked. Those were the two highest predictors. If I use all three, that second ranked, that was a 91%. And so what I've asked my software to do is not only tell me if there's a relationship, but of all of the variables, which ones are the strongest relationships. So number one, quiz and work are the strongest relationships with test scores. Number two, quiz scores, works, and how much time they spend on their homework is the second strongest relationship. And then you can see it just goes on down the line from there. Okay, so again, what this would allow me to do is it would allow me to write a regression equation. So here's my intercept, here's the slope for quiz, and here's the slope for work. So if I were, as an instructor, looking at my test scores and my quiz scores, I could tell my students, you know, there's a really strong relationship between how much time you spend in your homework, what your quiz score was for our unit, and how many hours you're working per week. There's a really strong relationship between those three. Notice that the slope right here on work is negative. That means the more hours you work, the lower your test score is. Increase your hours of work, your test score will probably go down. This is a positive slope, meaning the higher the quiz score, the higher the grade on the test. And that seems like it would be pretty reasonable to expect. So I just wanted to do a practical example, so give you an idea of how people might choose to do this in their own practice. With the Bell County data, you might look at whether the amount of poverty in a district as measured in the criteria in the county data, whether the amount of poverty or whether the English language status affects some kind of proficiency score. I'm not really sure what we'll choose to do with that data set, but here's an example of something from my own practice that I might be curious to investigate. Okay, so I hope that makes multiple regression and regression in general a little clearer, and don't hesitate to email any questions you might have.